I want to talk about now is another genre of assessment, if you like, a new and emerging genre of assessment around this concept of big data. So, so we've had select response assessments, we've had supply response assessments. What I want to say is that big data is a bit of select and supply, and it's more than that as well. It's a lot of stuff coming together, and one of the lessons around these new computer-mediated environments is that everything that the students do can be recorded, it can be analysed in all kinds of ways. So I want to talk about that by way of conclusion of these series of videos about standards and assessment. So I've got here a typology of types of data that are collected in today's computer-mediated learning environments. So this is, if you like, a typology of data types, right? So firstly, we have machine assessments, which are the machine extensions of traditional select and supply response assessments. So computer adaptive testing is the most advanced and sophisticated technological application of item-based assessments, supply select response assessments. So what computer adaptive testing does is it serves you the next question on the basis of your answer to the previous question. So let's say we ask you a question about something, you get it right, well, the next question's harder. You get it right, the next question's harder. You get it right, the next question's harder. Or, I get it wrong, the next question's easier. I get it wrong, the next question's easier. I get it right, another question the same. So what we can do is we can actually calibrate the questions that are coming to you to fit with your level of learning. So whereas we might have needed 100 questions to work out what your level of learning was, because some of them were just far too hard for you and there's no point in even asking those, and some of them were far too easy and there's no point in even asking those, we quickly calibrate the questions to exactly where you're at. And what it means is you need a bigger item bank. You need to go through the very difficult thing of grading difficulty across questions. You need to do all of that, so it's a lot of work and it's a big technological thing to do. So, but each person in the assessment does fewer questions, and we get an assessment which is more calibrated to who you are in the world. So now the other species of computer adaptive testing is computer diagnostic testing, where we can actually code each question by topic. So we can decide, look, you're quite good at this topic, but not quite so good at another. And we can calibrate the questions to find out exactly what you know about one topic as compared to another. So this is a very sophisticated regime. It has all the problems of traditional item-based assessment. What we're finding is a huge amount of computer adaptive assessment now, not only in high-stakes standardized tests, but also we're finding them embedded in textbooks. The questions at the end of each chapter, for example, are often computer adaptive these days in this new world of assessment. The other area which I mentioned before is natural language processing for supply response assessments. It is actually kind of interesting and kind of useful. For example, academic language level assessments, which actually say, look, you can assess academic language level by looking across the text using natural language processing technologies. It's kind of useful. So one of the things I want to say, working through the rest of these things, is these are different data types, and the more we have, the greater the variety, the better calibrated and the more accurate our overall assessment's going to be. So that's why this is worth doing, and what I'm really advocating is let's not abandon any of these assessment types, particularly as they move forward technologically. So what we have in the second area, the second major area of big data, is structured embedded data. So some of this might be procedure-defined processes. They're not so heavily used in the literacy area. They are heavily used in math, where you can learn algebra or geometry using intelligent tutors, simulations in science, games, and in a sense, these are procedure where the way it works is you reach a kind of decision point around a particular answer which takes you to the next point, and there are multiple decision points. The tree might go in multiple directions. You might be able to go in all sorts of directions, but it's procedurally defined where, in fact, the answer at each procedure point, there aren't many alternatives. There are a restricted range of alternatives at each decision point. Argument-defined processes are ones which involve some degree of interpretation. And in fact, rubric-based assessment can actually deal with argument in all kinds of ways. And in fact, the technologies that we have these days for doing rubric-based assessment, which is crowdsourcing the assessment across multiple students, having the teacher involved, self-assessments. In fact, we can have a lot of data being collected using these argument-defined processes. And essentially, argument-defined processes are processes which involve some degree of interpretation. So has this claim in a scientific argument been supported by adequate evidence, right? That can be assessed both in terms of a peer who gives you a score on that, which is, I think, in terms of your claims and evidence, I'll give you a 2 out of 3, and this is my reason why. So it's both a numerical assessment, but also it can be a qualitative assessment as well, where you put in a comment. And in fact, all that data can be added together. And let's say the assessment that I showed you before about an information text, which is a classic, argument-defined process. I don't mean argument in the narrow sense that it's used in the Common Core standards as different from narrative and different from evidence. I mean argument in the sense of based on arguable, if you like, based on reasoning. Okay, but one of the things we can do in computer-mediated environments is we can have lots of students doing this together, doing it simultaneously, and let's say we've got 5 criteria and 6 levels across three students doing peer reviews, plus a self-review, plus the teacher. We end up with a lot of data points and a lot of data, qualitative and quantitative, which these computer-mediated environments can manage quite well. And then what we can also have is what's called distributed machine learning processes. So what this is that we can have environments where the machine learns from a certain response and is able to then offer other responses later on. Let me give you a simple example. We're doing a science text and somebody uses a vernacular term when in fact there's a technical term which we should be using in science to describe the same natural phenomenon, and one student suggests a change from and marks it up, codes it with a little pull down coding as vernacular change to scientific. And then when that word comes again, we can make that as a suggestion for another student in the same way that reputational systems like Amazon and rating systems and the internet's full of these kinds of distributed machine learning processes. So we can build e-learning environments which have those in as formative assessment tools. And then the third area is what's called incidental unstructured data. So we have data incidental to learning activities, which is when you log in, how many keystrokes you do. There's a whole lot of stuff that's called data exhaust. And your patterns of interaction often can be shown to correlate with particular kinds of outcome. And if the patterns of interaction raise alarm bells, we might intervene. It might be something where something needs to be done, or there might be feedback to the student based on correlations with outcomes and patterns of interaction. And finally, we might have dedicated devices for collecting unstructured data. Classically, things like eye tracking in the case of reading. We might have movement detectors of all kinds. So if we have a lot of this stuff happening in the context of these new learning management systems and learning environments, we're collecting many, many different types of data, and actually thousands, in fact millions of data points. So how do we put the whole thing together? How do we put Humpty Dumpty together to produce an overall view? Well, in fact, people who design learning management systems are building visualization tools which hopefully can track students in productive ways, not only giving them constructive feedback as they learn, but bringing warning flags up when it looks as if a student is not on path or on track in terms of their learning. Just to give you one concrete example of this, in our Scholar environment, we've got a lot of things going on, all of which we can monitor. We can measure it So there's so much going on, in fact, that nobody can sensibly tell what's going on. There's class dialogue going on, students doing surveys, there's kind of social media activities, they're interacting with each other, they're drafting their works, they're giving each other feedback, they're giving each other revision, they're doing peer review. There's a lot of interaction going on, and in the center of it all, we have this analytics tool. So what we're doing is we're collecting a huge variety of data. The surveys, by the way, is item-based assessment of the old-fashioned variety. We call it surveys because we think of it as a kind of a knowledge survey. So across these different data types, natural language processing we use, rubric-based review in argument-defined processes, we do social network analyses of peer interactions, all of these things we can do. And from all those different things, build up a composite picture of student progress. So remember that kind of self-referenced assessment? Well, we can build progress reviews of self-referenced assessment, just how well are these students going along the way. So this is just an example that we've been trying to build of building these multiple embedded data collection forms into a learning management system and a learning environment. And this is one example of a data dashboard. We've wiped out the names in order not to for nobody to be identified. We can see that this is just one piece of writing, by the way, here. It's not all the other stuff going on. It's simply one piece of writing. We can see the number of versions you wrote, how much you wrote, the percentage edited, so to what extent did you edit your work after receiving peer feedback. We can look at your academic language level by doing a Flesch-Kincaid type analysis. In fact, we use Flesch-Kincaid and a number of other analytics to look at the level of academic language use, the vernacular compared to academic language. And those numbers, by the way, are grade level analyses, what we would expect a student's language level to be at that particular grade level. We can do an average peer review, and what we've shown in our research is the average peer review result is pretty close to what an expert or the teacher would give. By the time you've averaged it out, people's judgments are about right, particularly if you provide very, very clear levels descriptions, rating criteria and levels descriptions. We can look at your self-review rating. How well do you think you did at the end? And ideally, we want you to think you did really well. We want everybody to think they did really well because our objective is this criterion-referenced universe. We can have the teacher, in this case called the publisher. We can have them doing an assessment of the work. We can look at the number of reviews you authored. So in other words, we want to credit you for the contributions you make to others. We can look at the average review length. We can look at the number of annotations. And what we do in our Scholar environment is we create a score of 20-something different data points. So, in fact, in this assignment, which in fact involved 100 kids in a school, it was the whole of grade 7 doing this work, that what we do is we've analysed here actually 1 million words, multiple versions and lots of comments and the progress across versions, and this data is generated from a huge amount of material, and without machine assistance, no teacher could ever see this deeply into what students have done. And in fact, what the teacher can also do is they can go down further, dig even further into every student's work, see all the changes they made, the comments they got, the changes they made after their comments. They can see every single thing that happened during the whole process, as opposed to traditional summative assessment where you don't know how they got there. It's right at the end. It's too late for feedback. So this gives us a kind of an insight into what might be possible in this new world of assessment, of formative assessment. Here's an example of digging down into one particular student's work, just looking at one lot of reviews. In fact, there's a lot of data here which you can click through and you can get to quickly if you need to dig down deep into one particular student's activity, if you want to really interpret what was going on in their work. I'm going to kind of end with a definition of big data. I didn't start with a definition because I thought I'd describe what it was first and show you some examples. Big data is a kind of a controversial term. We're worried about it because it's the NSA, it's Big Brother, it's companies trying to sell us things, and it's invasion of privacy. It's a whole lot of bad things. By the way, in education, it could be a lot of bad things as well, so we better be careful. It could be profiling a student. So They don't get the opportunities they would have expected, and things are expected which lower their expectations. And there's a pile of worries and serious concerns around big data. But if we want to try to build a description of what big data is, firstly, it's the purposeful or incidental recording of activity interactions around learning. So because they're in these digital environments, we can record everything that's going on. We can keep a copy of it. In those environments, my second point is the data is very varied. It's messy data. It's everything from keystrokes to moves in games to peer review comments to item-based assessment. The data typology I gave you before, it's very, very varied. These data are actually relatively accessible. To go back through a pile of papers which has been hand-marked, it's not that accessible. These are accessible and they're durable. By and large, these things are not deleted. We can look at progress over a long period of time. And the fourth thing, the fourth aspect of it is data analytics. We can actually work back over this data and interpret what's going on, hopefully in a way which is very transparent to teachers and learners. It's not just computer scientists and statisticians working their voodoo to tell you you're a B+ or a C- or an A+ or whatever you are. But hopefully this is stuff which is incredibly useful to your learning and explains the reason for particular outcomes. To conclude, we want to conclude with a little slogan. The king is dead, long live the king. Well, the test is dead, long live assessment. So, traditional standardized summative assessments were problematic on so many fronts. They dominated the school system. They made interpretations in a short period of time which may not be fair to the person. Their questioning methods were problematic. They wanted to measure people against a single standard when in fact each individual's progress may be more interesting and may be more important. So lots of problems with traditional tests. Now, what if in this era of big data we can be constantly collecting information about the learner, which is more varied in its forms, which is comprehensive, where every little bit of information is concrete feedback which feeds back into the learner's learning activities? What if we can do that? Then we won't need assessments, which are expensive and painful in all these kinds of ways. So we might have an environment where there is no learning without assessment. There is no learning without feedback. These recursive feedback loops are an integral part of the learning process. Then we don't need tests. Then all we do is we have two types of interpretations of data. We have formative interpretations of data which in a very micro recursive feedback kinds of ways contribute to the learning. And then we can have these retrospective progress views which replace summative assessment. They simply look back on the same data and they say, where have we come from? Where have we got to? Self-referenced assessment. Have we met the criterion? And what we might even do if we want to do it, which we can do it, we might compare students across cohorts, classes or schools or regions or demographics. Are girls doing as well as boys at this? Are people of African American background doing as well as whites as this? And so on and so on and so on. We can do that comparative work as well. So what I'm arguing for is a kind of a holistic assessment environment. And I think, what I hope is not too far down the track in the not too distant future, that this big data regime will really help us to build a new world of assessment where assessment is integrally connected into instruction. They're not separate events. They're part of a reflexive knowledge ecology.